Hello guys, in this video I want to talk about the robustness testing, the second one. It's similar to input boundary value testing but with a little difference. So let's see. So robustness, let's start with one variable or more and take 7 value 1 2 3 4 5 6 7. Take minimum, maximum, nominal, minimum, -1, minimum, +1, maximum, -1, maximum, +1. So let's say we have one variable x, minimum, maximum, and minimum, let's say from 30 to let's say 90. So for variable x, take 7 value 1 2 3 4 5 6 7. As I said, minimum minimum -1, minimum +1, nominal, maximum +1, maximum -1. So for minimum is 30, minimum -1 29, minimum +1 31, maximum is 90, maximum +1 91, maximum -1 89. And to calculate the nominal, same rule, minimum plus maximum divided by 2. Calculator, 30 plus 90 equal, divide by 2 equal 60. So nominal equal 60. And in test cases we will have 7 test cases. Test case 1 will be first one, 29. Test case 2 equal second one, 30. Test case 3 equal 31. Test case 4 equal 60. Test case 5 equal 89. Test case 6 equal 90. Test case 7 equal 91. So this is summary of what I said in robustness testing. Just ignore this one. Let's take 7 value, minimum -1, minimum +1, maximum -1, maximum +1. This is for one variable. Now let's see if we have two variables. Let's say we have variable x and variable y, minimum, maximum, let's say from 30 to 60 and from 70 to 120. So we have two variables, x and y. X, y. For each variable sample value 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Let me erase this one just. Okay. For x, minimum is 30. Sorry. 30. Minimum minus 1, 29. Minimum plus 1, 31. 60. 59. 61. 30 plus 60 divided by 2, 45. The nominal is 45. And then y, 70. 69. 71. 120. 121. 119. Use calculator. 70 plus 120 equal, divided by 2 equal 95. 95. So there is one point we'll meet here from 29 to 69, and then here, and here, and then here, and then here, here, here. So each point is represent number. For example, this point, it represent the 29 and 69. But if you can see these points and these points and these points and these points, we call it extreme points. And in robustness, we don't take the extreme points, so we will not take these points and these points and these points and these points. Only we will take these points. So if you calculate the number of these points, it will be 13 points. Here 3, 6, 9, 12, 13. So we will have 13 test cases. But other way to find the number of test cases, if we have more than 2 variable, and here for 2 variable it's 13 test cases. If we have more than 2 variable, we have 3, 4, 5, 6 variable, we will follow this rule. It's 7 plus 6 n minus 1, and the n is number of variable. So if we apply this rule for this two variable x and y, 7 plus 6, 2 minus 1, 7 plus 6, this will be 13 multiplied by 1 equal 13 test cases. So test case 1 will be, let's take this point, which 29 and 95, 29 and 95. Test case 2 is, let's take this point, 30 and 95, 30, 95. Test case 3 equal, for example, let's take another point, let's say this point is 45 and 120, and we do that until we reach test case 13. That means we will cover all these points, okay. So we will apply this rule only if we have two variable or more. If we have two variable or more. If we have one variable, it's by default 7 test cases. For one variable, by default it's here, it takes 7 value, and it's by default 7 value, and by default it's 7 test cases. So this is a summary about robustness testing for two variable. We don't take the extreme point, we take these points, and we take 7 value. As I said, it's minimum plus 1 and minus 1, nominal maximum plus 1 minus 1. And to calculate the number of test cases, we will follow this rule: 7 plus 6 n minus 1, and the n is number of variable. So let's say we have example 3 variable x, y, z. If we apply this rule, it will be 7 plus 6, 3 minus 1, which is 2, 13 multiplied by 2, 13 multiplied by 2 equal 26 test cases. Thank you for watching. I hope you understand.